Okay, so where we left off was at number 18. I had suggested a scale of 1 centimeter equals 25 kilometers. When the video was ending, I had drawn my vector too close to the top, so while the other one was uploading, I backed it up. So here's my 195 kilometers, 7.8 centimeters long, and now I'm ready to add my 149 kilometers north, 33 degrees east. So you line this up with the very end and you mark the 33 degrees. From the north, you come down to the east. Okay, this one's 149. So 149 divided by 25 is going to be really close to 6. It's 5.96 centimeters. So balance the iPad. And this is going to be 5.96, which is pretty close to 6 centimeters. Happy to report it's not going to go off the page this time. Okay, put my arrowhead on. Label this one 149 kilometers. And the angle in here is the 33 degrees. Okay, so now draw your resultant in. This is going to be your displacement right there. Starting where the first one started, ending where the last one ended. If you measure it, I get 12 and a half. When I did it in real life, let's see, so I now need to go backward. 12.5 times 25 gives me 312.5 kilometers. When I did it on my own, I got 320. So it's probably going to be somewhere between maybe 310 and 325, maybe, depending on how accurate you were. All right, now take your protractor and measure the angle. I'm going to line mine like this and measure the bigger one, only because I think it might be easier. Wow, and the bigger one is like 86 or something like that. So if you measured the smaller one, it would be something like 4. When I did it on my other paper, I got 82 or 8. So if you measure this outside one, it's going to be somewhere between like 82 and 84. And in the inside one, it's going to be something between 6 and 8. Okay, so if it's the 82 one, it's going to be then from the east, 82 degrees, and we went north. Okay? If you measured the little one inside, it would have been north and then 8 or 6 degrees east. All right, so the first part of the question then says calculate the average velocity. And it tells us in A that the entire trip took 3.75 hours. So then the average velocity is just going to be delta D over delta T. So our 3, for me, 312.5. For you, whatever you got when you measured the length of your, whoops, be good if I wasn't off the page. Whatever you got when you measured the length of your resultant there. And when you do this, divide it by 3.75 that they gave us in the question. And so I get my average velocity to be 83.3 repeating kilometers per hour. A little bit deceiving though, because it actually went further. Average speed would be more accurate. Add the distances together, but it doesn't ask us for that. But it would give you a better sense of what the plane was doing. The B part says now the pilot's going to fly straight back. He's not going to do the two things. He's just going to come straight back. And so the time he does that in is 2.85 of an hour. And he wants to know what would the velocity need to be. So VAV again will equal delta D over delta T. The delta D is the same, 312.5 or whatever it was you got, but this time it's going to be divided by 2.85 of an hour. Oh, and by the way, the direction here would be the same, so east 82 degrees north. Okay, so how was that? So take your original length and divide it this time by 2.85, and you get 109.649 kilometers per hour. And which way would he have to turn to go back? Remember, when we turn to go back, we just switch east for west and north for south. Okay? All right. Skipping down to number 30, because I had said I'd come back to, number 20, because I said I'd come back to number 19 at the end. So number 20 says, a hiker sets out on a trek north 35 degrees east at a pace of, so VAV1 is 5 kilometers per hour. And he does this delta T1 for 48 minutes. And this direction was north 35 degrees east. So then his VAV2 is 44.5 kilometers per hour, and it's west. And he does that, his delta T2, for 40 minutes. And then he goes, his VAV3. Oh, no, they actually tell us the delta D here. 6 kilometers. So they give us, we don't have to find this one. Delta D3 is 6 kilometers. And it is north 30 degrees west. North 30 degrees west. That's really a 30 degrees west. 1.5 hours, delta T3, 1.5 hours. Okay? And so what we had talked about in class the last time I saw you was, before you can draw this, you have to actually find how far he went with each of these. So using VAV is equal to delta D over delta T, we can rearrange. So delta D1 will equal VAV1 delta T1. So delta D1 will equal 5 kilometers per hour, and 48 minutes is 4/5 of an hour. So delta D1 should be 4 kilometers. And the direction will be the same, north 35 degrees east. Okay, same idea for delta D2. So delta D2 will equal VAV2 delta T2. So delta D2 will equal 4.5 kilometers per hour. 40 minutes is like 2/3 of an hour. 2/3 of 4.5 should be 3 kilometers, and that's west. At least they gave us nice numbers. And then the last one's 6 kilometers. So now you're ready to draw it. Okay. I probably don't actually have enough room here. Oh, maybe over here. So I'm going to go northeast, and then I'm going to go west. Yeah, no, I don't have enough room. Let me switch to here. Okay, so let's pick somewhere down here. I'm going to use my finer pen. Pick somewhere down here. Make my scale 2:1 maybe. So 2 centimeters equals 1 kilometers. And the first one is north 35 degrees east. So north 35 degrees east. So line your protractor up. North 35 degrees east will be here. And this is 4 kilometers, which for me will be 8. Oh, I'm going to back up again because I think I'm going to run out. So let me start down here instead. North 35 degrees east. This way I'm not running out. Okay, so this is going to be 8. So from here to here. Oops, you can't see, but I promise I'm making it 8. There we go, now you can see. And so this is 4 kilometers, and this angle here is 35 degrees. Take your protractor, now we're going straight west. And we're going straight west for 3 kilometers.